Hello, everybody, and welcome to the TeamCity 15 Years of CI event. I'm Marco, developer advocate for TeamCity.
And I'm Jäger, the product marketing manager for TeamCity.
And we're trying out something new today from our brand new recording studio out of the JetBrains Munich office, actually. And we're trying to gently lead you through the evening, afternoon, maybe even morning if you're joining in from the US, or I guess after midnight if you're watching from Australia.
Yeah.
But in any case, we're going to have plenty of things planned. Before we come to that, why is this event called 15 Years of CI?
15 years of CI. It's because today, or rather this year, is the 15 years of TeamCity. It's the 15 years anniversary since the very first version of TeamCity was released in 2006.
It's actually crazy. I mean, the thing is, I'm a TeamCity baby, so I joined a bit more than a year ago, essentially. But then when you see TeamCity now, you can't even imagine. I think I checked our build server early on, and you have with JetBrains, we have 2,000 agents. We have roughly almost 50,000 different jobs running daily, or not daily, but in total on the build server. And it's hard to imagine what it must have been like at the very beginning with TeamCity version 1. And now it's become such a big thing.
It's true. Yeah, we use it basically every day. We use it to build all our products, IntelliJ IDEA, ReSharper, Rider, you name it. All the teams at JetBrains use TeamCity to run their CI jobs on it. That's true. And apparently, 15 years ago, it was not like that. It was not exactly the situation for JetBrains or for anyone, really, because there was no TeamCity.
Right.
Until one day, in October of 2006, it was released together with IntelliJ 6, if I remember correctly.
Mm-hmm. Do we still have... Oh, actually, I told you I've been part for a year. How long have you been part of TeamCity?
I've been part of TeamCity for almost 7 years now.
7 years?
Yes.
Which almost makes it half, okay.
Almost makes it half, but I still feel like a baby, as you call it, compared to some of our other team members who have been here. There are people on our team who've been here for the whole history of TeamCity, basically.
Is that true? Do we have someone who has been on the team for 15 years, or what's the longest time someone has been on a TeamCity?
I know at least 2 people who have been here with TeamCity for 15 years, and you also might know them if you use TeamCity, if you go to our issue tracker sometimes and file some of the issues. So the names like Pavel Sher or Kirill Maximov might be familiar to you because you might have seen those usernames there for 15 years straight, basically.
And I have to be honest, I find that super cool that we have people who have been part of one product for such a long time. They have the knowledge about the product. They have been developing it from the very beginning. It's very rare to find that in today's world, basically.
It is true. The team has developed as well, though, during this 15 years. So from just a handful of people back in 2006, it is now over 50 people running the development, the testing, the customer support, marketing, you name it.
Right. While we talk about the present, I mean, we touched a bit about the past just now. What is roughly the plan for the next 2 hours or so?
Okay, so the plan for the next 2 hours is to see several talks. So 5 talks to be exact. So there's going to be everything from what's new in TeamCity to testing TeamCity to running CI for game dev projects and to some of the hidden features of TeamCity, including also TeamCity Cloud, a talk by you, right?
Right, yes, yeah. Yes, I talked by myself. And I guess you also brought a surprise, which I'm not really aware of until now.
That's true. I have one more thing for you, Marco, and also for everyone joining. So we want to run a quiz of sorts.
Okay.
So what I have here is a couple of foam boards with some TeamCity features printed on them.
Okay. It looks like the run button. Okay.
You're right. Yes, I'll show it closer through the camera so that you can also look at that. So that's right. So there's a screenshot of a TeamCity interface or a piece of the TeamCity interface, which represents a feature of TeamCity.
Okay.
And the quiz would be to try and guess in which version of TeamCity or in which year, if it's easier, this specific feature was initially released.
Oh,
right.
Okay.
Okay, so I guess let's warm up with this. This is the simplest, I would suppose.
Okay.
So Marco, what do we see here?
Well, it looks like the run button. I almost have the impression it's kind of a trick question, because so we have the run button which runs a build, but we also have like these three dots with the let's run a custom build where you can select branches or whatever. Maybe the run button, I imagine, must have been there from TeamCity version number 1 essentially, but maybe with the extension that might have come later in one of the whatever version 2, 3, something like that. I'd say.
Okay. So this was a warm-up, so I'll give you the answer right away, and I will give everyone an answer right away for this one. So the run button, as you said, as you guessed correctly, was there from the very first version of TeamCity. It is meant to manually trigger a build to be run.
Right. Yeah.
So it's pretty straightforward. But you were right about the 3 dots, as you said it, or the ellipsis.
And you didn't show me. I mean, we didn't talk about this before, so I was being lucky.
So
here, yeah?
this was what you would see if you would press click the 3 dots or the ellipsis. So this is the custom run dialog.
Yes.
So the run custom build dialog. What it allows you to do is basically run a build with specific parameters, or choose a specific revision to run your build against. So basically run a historical build. Or choose a build agents to run this specific build, or leave a comment, run with a specific comment.
And let me actually take my guess back, because that looks way too complex to be in version number 2.
Okay.
So I guess, I don't know, 2006 we started, 2000, maybe an initial version, 2000, I don't know, 8, 9, something like that. 1, 2 years later.
Okay, so you're saying version 3 then?
Something like that.
Okay, we'll take this as your guess.
Okay.
We'll let you, everyone watching, please also take your guesses in the comments.
Please help me out.
Yeah, right there on YouTube. And we'll say the answer right after the next talk.
Right.
So what is our next talk?
The next talk, the first talk, is the new features of TeamCity 2021. In case you've been always wondering what have been the new exciting features of TeamCity 2021, that's your talk. It's exciting not just for, we're just going to give you a summary of everything that happened over the last year or 2 or so. Given by Alexander, and I guess we're just giving over to Alexander now.
Yeah, so from the very first feature of TeamCity, of version 1.0, to the newest features of 2021.
Yes, enjoy the talk.
Let's watch it.
Hello, everyone. My name is Alexander, and I am a product marketing manager of TeamCity. Every year, we release 2 major versions of TeamCity. And in this talk, I will give you a very brief overview of the new features that were released in 2021. Let's get started with authentication. This year, we've extended the list of authentication modules in TeamCity and added support for 2 new modules, Azure DevOps and JetBrains Space. If you are not familiar with JetBrains Space, it's a new collaboration environment released by our company roughly 1 year ago, and you are very welcome to go and check it out. In addition to these new login options, we've also added 2-factor authentication. With it, TeamCity will prompt you to enter a confirmation code from your Authenticator app on your phone every time you do the sign-in. Next, let's take a look at new and updated build runners. This year, we've added the new build runner for building Node.js applications. It has all the features that you would expect from it. It supports NPM and Yarn. It can work with public and private registries, and it automatically detects build steps based on package JSON when you create a new project. Just like all other build runners, you can run your builds inside a Docker container, see what changed, analyze failures, assign investigations, and so on. Just use all of your favorite features of TeamCity. Another new build runner is the Kotlin script runner. Kotlin is great, not only because it's the language that is developed by JetBrains, but because we believe that it enables so many new ways of building software. if you're like most of our users, then you're probably familiar with the command line runner, right? It lets you run arbitrary commands, but it also has a lot of limitations. Unlike command line, the new Kotlin script runner is cross-platform. It supports importing external libraries, and it integrates with all the TeamCity features. We believe that it will be great for all the scenarios where you currently use the command line runner. For those who don't speak Kotlin, we've created a similar runner that lets you write build steps using C# scripts. Say that you need to set up a build environment, manage some Windows processes, or simply move some files around. Earlier, your main option was to do it in PowerShell. And for many users, it meant Google how to do something in PowerShell, right? Starting with this year, you have the new C# script build runner. It is cross-platform. It works on any system with Docker, and it comes with built-in support for NuGet. And of course, it integrates very well with all the TeamCity features. In addition to the new build runners, we've updated the ReSharper inspections and ReSharper duplicates funder. They became cross-platform and can now run in Docker. And one more new feature is thread dumps for Docker-based Java builds. TeamCity has always allowed viewing thread dumps of processes running on build agents. However, when your build was run in Docker, this was very difficult. And now you can view thread dumps of Java processes running in Docker container, and this works on any operating system. Next, let's talk about our Perforce integration. Of all the different version control systems, Perforce Helix holds a special place because TeamCity plus Perforce is the de facto standard in many industries. And this year, we've added a lot to this integration. I will not describe every feature in detail, but this list includes improved commits hook setup, manual and automatic cleanup of Perforce workspaces that are created by the TeamCity server, support for the change view specifications, ability to run personal builds with changes from shelved change lists, the new Perforce shelf trigger, support for Perforce Swarm in the commit status publisher build feature, support for automatic labels in the VCS labeling build feature, and last but not least, parameterized connection variables that basically allow you to distinguish between different Perforce VCS routes if your project uses multiple Perforce connections. That was it for Perforce, and just a reminder, all of these features are available in all versions of TeamCity. If you want to check something out, just don't hesitate to go to jetbrains.com/TeamCity and download the latest version. TeamCity Professional is free, and you can just create a trial account in TeamCity Cloud and check it out right now. The next block of features is relevant only for the on-premises installation of TeamCity, not TeamCity Cloud. And this is about high availability that you get with a multi-server setup. This year, we've introduced the new main TeamCity node responsibility. This responsibility can be transferred to a secondary server in runtime. When this happens, the secondary server automatically receives all the responsibilities of the main nodes, including processing builds and managing build agents. So this basically gives you failover. You can continue working with TeamCity, running builds, doing your work, while your main server is under maintenance. One more high availability feature that was also added this year is the ability to control the number of builds on secondary nodes. Now you can define the share of builds that will be processed by each of the nodes. And just make sure that every server takes just the right amount of the build processing load and doesn't exceed its hardware capabilities. Next, let's talk about security. I've already mentioned that we've added two-factor authentication. But we have many other features and bug fixes and improvements. Now you can generate access tokens that are limited in time and scope. Say that you have a script that interacts with the TeamCity API, and now you can give it just enough rights to do its job, without the fear of giving it too much power. You no longer have to remember to revoke the access after the script finished. And this is the new access tokens. Another new feature is a separate permission for running personal builds with custom patches. This feature basically helps you ensure that all the code that is executed on build agents is authored only by the trusted users that have this permission. Next, let's talk about new core CI improvements. Starting this year, build triggers can now define custom parameters that can enable or disable build steps or change what happens inside your build scripts. For example, say that you have a build configuration that creates some build artifacts. Now, your nightly build that is triggered by a schedule trigger can be different from the build that is triggered by version control check-ins. Git shallow cloning. It lets you check out the latest version of source code with depth equal to 1. If you spin up clean, short-lived build agents in the cloud for every build, you don't need to create local Git mirrors on them, right? You only need the latest version of your source code. And Git shallow cloning lets you do exactly this. And we've removed the limitation of having only one VCS trigger per build configuration. TeamCity now allows you to add multiple triggers with different rules and different branch filters. For example, your release branch can be built immediately after the commit, but all other branches can have some different logic. For example, they can wait for their own VCS quiet period or some other settings. And finally, let's talk about the new Sakura UI. We're continuing to further improve it, making it faster and easier to use. And we've added a new UI assistant that shows new users how to navigate around the user interface. There we have improved the build status widget, updated the pending changes view, created new change details preview, added user avatars, and much, much more. This is Sakura UI. Yeah, basically that's it. So let me quickly run through what we've covered today. Authentication. There are new external services and two-factor authentication. New build runners, Node.js, Kotlin script, and C# script. A lot of great improvements for the perforce integration. New high availability and security features. Core CI improvements with trigger-defined parameters, support for multiple VCS triggers, and more. And Sakura UI improvements. And this is not even mentioning a lot of minor features, usability improvements, performance improvements, bug fixes, and other features. So we highly recommend you to update to the latest version if you're not there yet. We've already started working on TeamCity 2022.1, and if you don't want to miss the news, just don't forget to follow us on Twitter or subscribe for product updates on the JetBrains website. And thanks for your attention. That's it.
Welcome back. That was a nice overview of the new features in TeamCity 2021. Actually, Igor, what is your favorite feature, if I may ask?
Yeah, there's so many features, it's hard to kind of choose one. But if I were to just point it to a direction that is personally my favorite, I would say it's the scalability and high availability features.
Right.
So the additional responsibilities that you can assign to the servers to make sure your setup is scalable and highly available. Mm-hmm. This is a super important feature for a lot of our larger customers, and we know that for sure because we've been getting a lot of feedback about that, and hopefully we'll be giving more of those features to them. Mm-hmm. What about you?
Good question. On one hand, my developer, whatever genes, who say I need new shiny stuff, they say, well, the build runner is always cool, C# build runner, Kotlin script runner. On the other hand, for whatever reason, I enjoyed the perforce changes a lot because I hadn't done much with perforce previously, and it kind of forced me, no pun intended, to get used to it and to know, how to handle it. So that was interesting to see. So I'm going to go with the perforce integration, actually.
Yeah, and you've done the video about all the new perforce integrations, right?
Yeah, and that's why I really had to, I don't know, dig deep and get into get my knowledge level up.
Yeah. If you're looking to learn about the new perforce features, you can also watch the Marco's video on our What's New page on the website and the blog. It's pretty awesome, I think.
Yeah. Which brings us to something I've been waiting for. What is the solution to the question?
Right. So just to remind you, the question was, when did this feature of TeamCity, the custom run dialog, appear in TeamCity? And the answer to this, and actually there was someone in the chat who guessed it correctly. So the answer to that is version 4, TeamCity version 4.0, that was released back in 2011.
In 2011?
2011, correct. So the run button was there from the very first version, but the custom run was added a bit later after that. Which brings us to the next question.
Okay.
Are you ready for that?
Yeah.
Okay.
Bring it on.
So the next one is a pretty cornerstone feature of TeamCity. Let me show it to our viewers as well. So this is...
On the first look, it looked like build chains, build pipelines.
Correctly. Yes,
right?
This is correct. So this is the build chain. As you know, and as I guess a lot of our viewers might know, build chain is quite an important concept of TeamCity, right? Mm-hmm. So when do you think it was first introduced in TeamCity?
Again, there doesn't seem to be any easy questions for me. It's interesting because, with build chains, we have a slightly different take on build chains in TeamCity with the snapshot dependencies and basically almost having some sort of a pull model with the build chains instead of a push model like in many other tools. And again, I don't think that has been in there from TeamCity version 1. The custom run dialog, we said 2011.
2011, right. 4.0, this is when it was
4.0. Yes. So I'm just going to go build chains, initial version 3.0.
Okay, and just to remind our viewers that how the TeamCity versioning works is up until 2017, the versioning was based on just the sequential number. So 1.0, then it was 1.1 for the second release a year. So there's generally 2 releases per year, and then it was 2.0, 2.1, 3.0, 3.1, etc. And then we switched to 2017.1.2, and then we're keeping with the year version now. Okay, so your guess is 3.0.
3.0.
Whatever your guess, please feel free to post it in the chat, and we'll give you the answer. And you also after this next talk, which is
a talk by myself, actually.
Okay.
So as I'm heading on to the talk now, I guess you have to do the tiny introduction.
All right. So this is going to be a talk about our latest released, not even a feature, but I would say even a product. That is TeamCity Cloud. Marco will take us through setting up your first TeamCity Cloud build, registering for TeamCity Cloud, and running your build and working with the results of that build. So Marco, feel free to get started. Let's watch it.
Well, hello again, or in case you just tuned in, hi, I'm Marco, and I'm going to give you a quick run-through TeamCity Cloud so that hopefully you'll have a successful green build of your project in a couple of minutes with TeamCity Cloud. For that, you need two things, and you can actually follow along because I don't like slides. Everything I'm going to do is going to be live coding / live configuration. And essentially everything I do, you can also just repeat and do yourself. So jetbrains.com/teamcity/cloud. And then you also need a repository. I prepared a Java Maven repository, and it doesn't matter too much if you're not comfortable with Java, because I just want you to get an up and running build. So copy my repository for now, and then later on you can just repeat the same steps with your repository and different languages, Node.js, C#, Python, whatever have you. Okay, so I copied my repository URL. I'm going back to the TeamCity Cloud homepage. Obviously, you could scroll down, tons of information, pricing and whatnot. For now, I only want you to put your email into the email box. So I'm just going to put my email here. I want to start building for free. I'm getting an email now, which I'll just quickly get, right? Click the activation link. Now there's a registration page, which is the most boring part of this demo here. My company name. Yes, I have read the license agreement very carefully, right? And now I can choose my TeamCity domain. What I'm going to do is I'm just going to choose 15 years, TeamCity.com, proceed. And now it's going to take a while. What's going to happen in the background is that we actually spin up an entirely new TeamCity server for you in the cloud, or more specifically in AWS. A TeamCity server is basically the TeamCity server software, which is going to be deployed in a Docker container in Amazon EC2 in the Ireland region by default. And then also there is an RDS instance, which is being spun up. So you have an isolated database where all your data actually goes into. And as you can see, it says, well, it said it can take up to 2 minutes, but that was actually pretty quick. So all of what I just mentioned happened in the background, and you're able to just, join TeamCity Cloud now, which I'm going to do. I could log in with a username and password, or for the first time, I'm just going to choose login with GitHub. Right, I'm going to choose markobila@jetbrains.com, put in my password. I'm just going to sign in, put in my verification code, and I'm being redirected straight to my TeamCity instance. Now again, what I'm going to do is I'm going to carefully read the agreement here. Even scrolling down takes some time, but I do agree, right? And then I just have to wait a couple of seconds more, hopefully, and I will be prompted with my fresh 2-week TeamCity trial account. Now, what you'll see at the beginning is the TeamCity overview page, where you don't have any projects yet. So there's nothing too exciting going on here. And what we're going to do now is just create a new project. So just click the button here, and you'll be prompted with the Create Project Wizard. There's a couple of choices that you can see here from GitHub.com, from Bitbucket Cloud, GitLab.com. And because we just logged in with GitHub, we actually get a nice little drop down of all my GitHub repositories down here. But if you haven't logged in with GitHub or just did a manual registration, you can always just as a default go with create a project from a repository URL. In here, what you're going to do is you're going to paste in your repository URL. You don't need a username or password in this case because it's a public repository. I'm going to click proceed. And what happens now is that TeamCity tries to connect to my repository and does the first checks. Well, does the repository exist? Was the username, password, or the access token correct? And as you can see, that worked. And now TeamCity says, well, I'm going to create a project with the same name as your repository. The URL is going to be the GitHub URL. Default branch means that TeamCity is going to poll your default branch every 60 seconds by default for changes. So that's the main branch. And that is proper git speak refs heads main for that. And there's also a branch specification, which says not only do you want to poll the main branch, but actually every other branch as well. So if you have feature branches, production branches, staging, whatever, all of these would get polled for changes rather, and builds are being triggered. Now, I skipped one field here, the build configuration name. And build configuration, if you come from other tools, every project needs to do something, and that something is a job. In TeamCity, jobs are called build configurations. So we also need a build configuration. At the moment, it's called build because it's just, gonna build our entire project. I'm gonna click proceed again, and we're almost done here. There's just one last step. And again, it shows a bit of how TeamCity tries to be smart, because now TeamCity scans your repository and sees, well, your repository, actually, let me just open it up in GitHub again, has a POM.xml file. POM.xml file is always a signal for it being a Maven project, a Java Maven project. So TeamCity says, hey, it looks like I found a POM.xml file. Why don't you just want to run Maven clean test, which compiles your code and which tests your code? And all of that is going to be bundled in a so-called build step. So every build configuration / job in TeamCity needs build steps. One of these build steps is a Maven build step. And yeah, why not? Let's go with that. So I'm just going to hit use selected. I'm going to get a pop-up here. I got it. I can run the first build. Let's actually run a build and see what happens now. Because I'm now being redirected to our home page again. As you can see, there's now a project. Here is our build configuration / job. You can see there's a build queued, right, waiting for starting agent. There's already a build log. You can see something is happening on a TeamCity server. But actually, the interesting thing is the build doesn't really happen on the TeamCity server. It happens on a so-called agent. You can see agent Linux small here. Now, where does the agent come from? And while the build is running, let's talk a bit about the TeamCity agents. Now, you'll find a tab up here, which is called, unsurprisingly, agents. An agent is any machine. It could be running in the cloud. It could be running on your machine where the TeamCity build agent is actually installed and up and running. And the builds always happen on these agents. They don't happen on the TeamCity server. The TeamCity server is just a UI, and the agents run the builds, and they send the log files and everything, the build results, back to the server for you to display. Now, by default, what's going to happen in the cloud, that we spawn up these build agents for you dynamically. So you want to run a build, and we just spawn up a build agent for you. If you have a look at the default section here, you can see there's different types of build agents. So a Linux medium build agent, Linux small agent, a Windows medium agent. When you click Linux small, you'll actually see there was a running agent instance a couple of seconds or a couple of minutes ago. It has already been stopped because they get actually spawned up and then killed after a build. So you always have a clean agent, right? And when you go back to the TeamCity Cloud homepage and scroll down a bit, you'll also find that these agents have obviously different characteristics. They have different CPUs, they have different RAM, and they also have a different pricing model. But this is just one way. So for example, we manage the agents for you. You spawn them up. You just tell us what agent you want. And by default, we're just going to spawn up the cheapest choice, so Linux small for you, but you can also change that, obviously, for your builds. And then what I also would like to show at the end is how you run your builds locally, or rather you have your agents running locally on your machine, or my laptop in this case, and connect to your cloud instance. But not so quick. First of all, let's go back to the TeamCity server projects. Let's have a look at the build. As you can see, the build was successful. Build number 1, the main branch was built. 3 tests have passed. That was the Linux small agent. It took 37 seconds to build 2 minutes ago. Great. Let me show you some concepts of TeamCity. I'll open up the build. So again, you'll see here's an overview page, just repeating what you just saw on the main page, where you had all the other builds. Actually, let me just run another build so that you'll see here a nice table of all your builds. But when you have a specific look at one build, then you'll have the changes tab, which shows you actually, for now, it just shows the revision that got built. But in fact, if someone pushed a change now, or pushed a commit now, you would see the push and the commits that triggered the build here under the changes tab. You'll have the build log, obviously, so you'll see what happened. It's a smart build log. You can even search inside the build log pretty quickly. So if you put in Maven, you'll find all these. You don't even have to download the build log anymore because the search actually works pretty performantly. A couple of other tabs, but what I want to highlight is the tests tab. Test support is pretty cool in TeamCity. What you'll see is that, well, for this build, there were 3 tests. They were all successful, all green. There was a syntax checker unit test, which took 46 milliseconds. There was another unit test, which just took 2 milliseconds. There was a slow web service test, which took 5 seconds, right? You see the order in which the test ran. And also, you always have a test history. When you look at a specific test, like the fast test here, we just triggered 2 builds. And you can see that, well, it took 40 milliseconds in build number 2. It took 46 milliseconds in build number 1. You also have that here in a nice little graph, which just for 2 build runs isn't too exciting. But essentially, you have a pretty good overview of what your tests did in the past, how they behaved. You have graphics. You even have flaky test detection, where TeamCity can tell you, hey, this test is starting to fail, even though there were no changes pushed. So all of that sort of stuff you can explore in TeamCity. Right, now we have that. That was the basic intro into, well, how to get your first build up and running with a ton of, let's say, TeamCity magic, because we just put in our GitHub URL, and then TeamCity auto detected everything it wanted to do for you. But what we're now going to do is, I just want to give you, some of the core main TeamCity concepts so you're not entirely lost when you're trying this yourself or when you're using other programming languages for that matter. Go to your project, edit the project, and what we're going to do is we're just going to have a look at the build configurations here, the one that TeamCity created for us. And what we're going to do is we're just going to delete the build configuration, because now everything that TeamCity did for us, we're going to do manually and learn a couple of things along the way. So let's create a new build configuration. We'll just create a manual build configuration. We're going to call it build again, right? That is pretty similar to what we did before. And then here you'll find now that our build/job is opened up. TeamCity wants us to have a look at the version control settings first. It says, please attach an existing VCS root. VCS root is TeamCity speak for your repository. And what you want to do is your project has that one repository at the moment. Note, there can be many repositories attached to a specific project, hence the drop-down list. But for here, we just want to go with our one repository. Then TeamCity is trying to do the same, build step magic again. But we don't want to do that. We want to configure that manually. So I'm going to click this link here, right? And now what you can see is I'm here in the build step section. TeamCity tells me add a new build step. That's fine. What specific runner should that be? And basically a runner is every technology in TeamCity that we support. We have a specific build step runner for it. So for example, if you want to build something .NET-y, you're going to go with .NET. If you want to do something with Docker, choose a Docker runner. If you want to build a Gradle project, go with the Gradle runner. Maven, Maven runner. Node.js, Node.js runner. Python, whatever. So you can see that for every technology/framework, we have specific runners. And we're going to go with the Maven runner for now. The Maven runner is going to take a second, and it's going to prompt us with a couple of options that only make sense in the Maven context. So, for example, what are the Maven goals we want to execute? Before or earlier, we executed Maven clean test. Now let's execute Maven clean package, which takes our source code, compiles it, runs tests, and also creates a package, a jar file, which I then can later on, deploy somewhere else. Or even, wrap inside a Docker container, upload it to a registry, whatever you want. Path to POM XML file. Remember, it's in our repository. But in case you missed that, you have many smart icons in TeamCity. One of these smart icons is here on the right side. When you click it, you actually get a browser through your Git repository, and then you can simply, click through all the folders and find your POM XML file. I'm just going to go with the POM XML file in the root. What you also can do, and that's a pretty cool feature, run the step within a Docker container. If for whatever reason you're unsure of what is installed on the build agent, And by default, on our cloud build agents, we install pretty much everything that you might want to build. But imagine you have a Docker container, you want to run Maven clean package inside a Docker container. Like, for example, take the latest Maven image from Docker Hub and run it inside there. Easy, you just put in the image coordinates and that's it. You could even say, well, Linux or Windows image, whatever, a couple of other options, but for now, this is all you need to do. When you have a look at the advanced options, you'll see you even have more options. Do you want to run with a specific Maven version, a specific JDK, incremental building, Maven specific options? So everything that has to do with Maven. And these options, obviously, if you wanted to run command line scripts or shell scripts, you will find that the runners can configure your build tool or whatever you're trying to do with any option you'd ever like to use. Right, so I'm going to click Save. That looks good. So what we did is two things so far. Repository, we also have our build step. And then I'm going to give you just something on the way. What you want to do is not failure conditions, but triggers. Triggers is a big concept in TeamCity because at the moment you have your project set up, but no builds are being triggered automatically. You can change that by adding a trigger like a VCS trigger. If you want to run builds when someone pushes changes to your repository, you have a schedule trigger if you wanted to run builds on a cron basis, for example, right? Just to show you, the schedule trigger tells you when daily, 12 o'clock, whatever. What I want to do is just go with the VCS trigger at the moment. There's even more advanced ones like build the project whenever a dependency in a POM.XML file changes. So have a look at those, right? But for now, just any build in any branch, any commit in any branch should trigger a build. We're just going to go with that. And last but not least, before we just run a build and hopefully everything is still working, think about what I mentioned earlier, that the build happens on the TeamCity build agent. And these machines are being booted up and they're being killed again after the build. Now I'm trying to build a jar file, but the jar file is going to be gone after the build agent is being killed or has been killed. And we need a way to transfer the jar file to the TeamCity server so it gets a hold of it. And then the TeamCity server can take the jar file and give it a different job later on that wants to deploy the jar file, for example. And in TeamCity, you do that by saying my build has an artifact, a so-called artifact. In JavaSpeak, or in MavenSpeak rather, the jar file will end up in the target folder. And I just want TeamCity to take any jar file in the target folder and upload it to the TeamCity server so we get a hold of it. Right. These are the main concepts. You'll need to understand repositories or version control settings, build steps for your languages, triggers, and also artifacts if you want. All right, now that is enough. Let's actually trigger just another build. Wait a couple of seconds, and by now you should be actually used to it. As you can see, the build has been queued. You can see the build, we're waiting for a starting agent. And hopefully that will lead to a green build again in a second. While that build is running, let me show you one final concept. I told you at the beginning, there is the possibility of running your own build agents locally or in your data center, wherever, and connecting them to your TeamCity Cloud instance. If you want to do that, you will go to the Agents tab, then click Install Agent and download an agent. By default, you could just go with the full zip distribution file, put it somewhere on your PC, and unpack it. And then the agent needs to run and it needs to connect to your TeamCity Cloud server. And for that, you need a couple of settings, also an authentication token. So use that menu again, use authentication token, download config, give your agent a name, so 15-year agent, for example. And I'm just generating and downloading such a file. Right. Now, let me show you what to do with that. I'm going to open up my downloads folder. I have my build agent properties. I'm just going to quickly take that with me. Go inside the build agent directory, which I already downloaded unzipped, conf folder. I'm just going to copy my file in here. So here's my properties file, right? And then I'm just going to open up a command line. cd downloads, build agent, build cd downloads, cd build agent full, cd bin, I think it is. Let me just double check. Agent bat start. Now what's going to happen is that my agent locally is booting up. It says looking for installed Java. The Java executable was found, JDK 11. And now actually the build agent is booting up, and hopefully it's going to connect to my TeamCity Cloud instance in a second. Right. Meanwhile, while that's happening, let's have a look. You can already see there's now the agent is here, but it's still red because it hasn't yet connected, which it hopefully will do in a second. And meanwhile, while that's happening, let's go back to the project. You can see that the build is running. Let's see what it does. Right. Step 1 is still executing. Maven step number 1 is running. You can actually have a look at it. You can see that, well, there was a Docker container running step within a Docker container, Maven latest, that worked. So what actually happened is that TeamCity downloaded a Docker image and ran the Docker container successfully. You can see there's a ton of dependencies being downloaded here for the first time, right? And let me just go back to the overview page. And now I guess there's a quick race going on between what is going to be faster. Is my build finishing faster here, or is my cloud agent connecting faster? Tests have passed 3 publishing artifacts. That looks pretty good. So it's coming to a close in a second, right? Build is done. As you can see, the build is running perfectly, just like it did before. Tests have passed, 3 different tests. The only thing I want to highlight here is that we can now have a look at this artifacts icon over here. And you can see there's suddenly an artifact which I can download or even browse inside these magic icons again. That's my jar file which came out of my Maven build step that we created by running Maven clean package. And now I can actually see it here, right? My TeamCity build agent is popping up and doing an upgrade, it seems. Hopefully it's going to be done in a second once I click that tab over here. But just to finish off, you'll have your artifact here, so you can download it. With a jar file, it might not make too much sense, but a prime example, for example, would be log files. You just get all the log files from your build agents, put them here, or even videos. If you run tests with headless browsers, you can get your test videos, your browser videos, just transferred here, and you'll see if a test failed, you'll see the video, why it failed and whatnot. Pretty super cool. But also if you want to run build pipelines later on, you need these artifacts so that the TeamCity server can send them to other build agents later on down in the pipeline. Right. This should all be clear. Let's see what our agent does. Our agent is still disconnected. And let's do a tiny time warp and hope it will finish in a second. Right, whoops, back again. That happened pretty quick. As you can see, the agent is now connected. You can even see the operating system that I'm running on, the CPU rank, the host name, all that sort of stuff. And if I now start running builds, they will use my locally connected TeamCity agent, even though there's a different licensing. Have a look at the TeamCity Cloud homepage, because with these local running agents, it's all about how many of parallel builds can you actually run. Right, but to sum things up, to not confuse you too much more with many more concepts, we learned a couple of things. You can get started with TeamCity Cloud pretty easily. Just put in your repository URL, let TeamCity do its magic, scan your repository, and then just say yes, essentially. Other than that, just remember there's a couple of concepts of build configurations / jobs in TeamCity. You need build steps with these runner types, Maven, Java, Python, whatever have you. You have these triggers. You also have the artifacts. And that should get you started with pretty much any project you would like to build in TeamCity. Now it's your choice. Give it a try. Try it out. Let us know what you think. But in any case, I think that's enough for now. And it's time to watch some more other talks. Or if you're watching this later, then I'm just going to say bye.
Okay, welcome back. Marco, welcome back as well. That was a talk on getting started with TeamCity Cloud. Thank you, Marco, for doing it.
That was fun.
Yes. So as you could tell, TeamCity Cloud is a pretty important, I wouldn't call it a feature even, it's a pretty important release for us, right?
Yes, it is.
So the team, it was a humongous team effort this summer.
Yeah, I mean, I guess that the complexity lies in we want to shield all the hosting from you, essentially. And as you just saw, I mean, it's easy to get started with TeamCity Cloud. You don't have to do much. We host the whole infrastructure, everything agents for you. And that took quite a considerable amount of, engineering effort to make it as smooth as possible for you, essentially.
Correct. And now we basically gave access to TeamCity, all the power of TeamCity, but in the cloud.
Yeah.
In a SaaS managed environment.
Yes, and you can still, as you saw with connecting your own build agents, your local build agents, still you have some flexibility. So it's not just you're not limited to just what we are offering, but can modify as you want.
Right. And also just a shout out to all the beta and the private beta users of TeamCity Cloud. They were giving us a lot of feedback, and that were helping us shape the product as it is right now.
And to the TeamCity Cloud team.
Of course, yes, that goes without saying. And there's more to come, of course. It's just the first year of TeamCity Cloud. There's Mac build agents are planned. The prepaid monthly build agents are in the pipeline. Maybe even for this year, we'll see. We'll see how it goes. And definitely more things coming next year. So stay tuned to TeamCity Cloud if this is relevant to you.
Now, as always, tell me.
Okay. Build chains, yeah?
Build chains.
Build chains. This is what we've been talking about. And before I give an answer to this one, I have to correct myself about the previous one, because I said that version 4.0 was released in 2011, but it was released in 2008. And thank you for pointing out in the chat. And of course, that was a mistake on my part. 2008, that was the custom build run.
Right.
Now for the build chains.
Which means I wasn't too far off. I said, I think 2.6, 2.7 or
yes, you were quite close. You were quite close. So for the build chains, what was your guess? 3.0, right?
3.0.
So the answer to this is 4.0. Again, just like with the custom run dialog. So apparently 4.0 was a big year for us. So 2008, that was a big year again. 2 big features released. And of course, with build chains, the snapshot dependency, the artifact dependencies, and the fact, as you said, the pull concept instead of the push concept, those are the important pieces of the product.
Yep.
Next up is not exactly a TeamCity screenshot. And you might be familiar with this one.
Right.
To our audience. So what does this look like to you, Marco? Tell the people.
Well, what it looks like is a Kotlin build script. It looks like our Kotlin DSL. TeamCity's Kotlin DSL. It's just a very simple build. As I can see, a Gradle build. It does a Gradle build and an npm install. Interesting. But in any case, to give you an idea, it feels, I would say, TeamCity 2017. I'm pretty specific about that, because I imagine I did quite a lot of stuff on Kotlin DSL, and there have been imports in the Kotlin files which reference 2017. So I think 2017.
2017. That's a pretty accurate guess. But we'll find out if it's true or not after the next talk. As you said, Kotlin DSL is a new way to configure builds in TeamCity.
Yes.
If you don't want to deal with the UI, although I find the UI is a very important piece of TeamCity also, but there's also an option to configure your builds, configure your projects through Kotlin DSL. There's also an option to combine both of the ways. So you can do that in the UI, and you can do it in code, and just run this hybrid approach, because maybe not all the teams are familiar with it or are comfortable with a configuration as code approach. Right?
And please have a look. I made a video, like a 1 hour getting started, a quick start video into Kotlin DSL, which shows you everything basically you want to know about how to get started with it.
Yeah.
Also to avoid some pitfalls. Have a look at it. It's on our YouTube channel.
Yeah, and the reason I chose Kotlin DSL before this talk is it will be mentioned in the next talk, which is what?
Right. The next talk, if I'm not mistaken, is going to be a CI pipeline for Unity games, a topic which I literally know very little about. And that's why I'm actually rather excited to see what it's like, given by Daniel.
Yeah, same for me. Don't know much about game development, but it's amazing how many game development companies and studios and teams, big and small, use TeamCity.
Yes.
So let's see how it's done by Daniel.
Enjoy the talk.
Hi everyone, welcome to my session. I'm going to be talking today about building Unity games using TeamCity. So let's get started. First of all, I'm going to create a new project in Unity, and I'm going to store this in a workspace I've created in Perforce. So over in P4V, I have a depot called Unity Games and a workspace under my user directory called Unity Games also. So if I jump back to Unity Hub, I can create a new project. And for this, I'm going to call this game my super awesome game. I'm going to save this in the Unity Games folder. And I'm going to create this from an existing template. So I'm going to select the 2D platformer micro game and click create. This will go ahead and create a new project. It will resolve all of the packages, bring those in, and create the project for us. Okay, so now the game has been created in Unity. So we can, let me maximize this. And I'll also close the tutorial section on the right here and expand the canvas. Now this game comes with a sample scene, which I can expand here, and we can select one of the views, so from the player view. And if you're not familiar with this sample game in Unity, essentially you have a player that can go along this environment and collect these tokens, which are these yellow or gold diamond-shaped tokens. And we can preview what this game looks like directly inside of Unity by clicking the play button up here. And then we can just run through the game. And you can see you can collect these tokens and avoid the enemies. So quite a simple game, but quite interesting. So one of the first things I want to do is add this game into Perforce. I want to store this code because we then want to set up the project inside of TeamCity. So to add the project to Perforce, I go to the Edit menu, Project Settings, and under here I can select Version Control, and we'll change the mode over to Perforce. This is one of the built-in integrations offered in Unity. And I'm going to enter my credentials, so my username for Perforce, my password, and the workspace, which will be Unity Games, and the server, and that's where Perforce is currently running. So I'll click the connect button, and that connected fine. So we'll close that. And on the window menu, I can go to Asset Management, Version Control to bring up the version control menu. And I'll add this as a tab down here just so it's easily accessible. And if we expand that, we can see all of the files that will be added if I was to check this into source control. So I can actually go ahead and click Submit. And I'll call this my initial commit. And that's submitted successfully. And if I go over to P4V, I can go to Depot, click Refresh, and we can see the super awesome game now shows up in Perforce. One of the things I want to do though is, in order for TeamCity to detect that this is a Unity project, there are a couple more files that need to be checked in. So I'm actually going to, inside of the P4V, I'm going to add the whole super awesome game folder. So I'm going to mark that for add. And I've already defined a global P4 ignore file. So we're not worrying about checking any of the library files, any of the packages, the temp folder. That will just take up extra space on the server. So we can see all of the ignored files here. So I click OK. And there are also some files with wildcards which we'll exclude as well. And then if I go over to the depot folder again, click refresh. Okay, so if I click submit, I can call this my initial commit again. Click submit. Okay, so now we have the entire project checked into Perforce, I can refresh. We can see all of the required files for this game are now stored on Perforce. And one of the next things I want to do is, in order for TeamCity to trigger a build of this game, I want to create a C# class file that will define the two types of builds I want to create. The first one will be a macOS build of this game, and the second one will be a WebGL version of the game which I can play inside the web browser. In order to do that, what I can do is go to the Assets menu and open this C# project, and this will cause the Rider IDE to be opened. I have this installed on my machine, and this will open up the Unity project inside of Rider, and we'll just wait for that to load. Okay, so the project has opened up inside of Rider, and in the folder structure here we can see there is an editor folder which has an existing class file, C# class file already in there. So I can right click on this folder and go to add a new class, and I'm going to call this my game builder class, and it will go ahead and create that new C# file, and I'm going to actually paste in some code I prepared earlier. And essentially what this is doing is we have a class called Game Builder, and it contains two methods, one called perform macOS build and the other called perform WebGL build. And what these do, the macOS one, if we look at this one first, we define which scenes we want to include in the build. I've also defined the output path, so it's going to generate an application called Super Awesome Game, which exists under the build macOS folder. I've also defined the target as being a standalone OS X or standalone macOS game. And then down here, the build player takes those options and generates a build based on those configurations. And then further down, if we look at the WebGL build, it does a very similar thing. It takes the list of, or the array of scenes. We define a output path, which is build/WebGL. I've defined the target as WebGL as well, and it proceeds with the build of the game. And also, if you look, there's a attribute tagged onto each of these methods, which adds a menu item inside of the Unity UI. So we've added menu items for both of these methods, which means both of these methods can be called directly inside of Unity. So if I jump back to the Unity IDE, we can see that there is a new build menu, and I can build a macOS version of the game or a WebGL version of the game just through those new menu options at the top of the screen. But we want to run this build inside of TeamCity. So in order to do that, I want to first of all check in my latest changes, because we can see that Unity has detected that new Game Builder class. So I can right click on here and submit those changes, and I'll just say I've added the Game Builder class and click Submit. And now if I jump over to TeamCity, I've got TeamCity running on my local machine here. So this is my local host version of TeamCity. I have one project in here at the moment just called Hello World. I'm not going to go into that one today. I'm going to create a completely new project for this game. And in order to do that, I click on the New Project button in the upper right corner. And the nice thing with TeamCity, if you just type in the URL, it will figure out how to connect. So if I type in the repository URL, which will be Perforce, and then the host name or IP address where Perforce is running, and it'll be under depot, and it'll be called Super Awesome Game. And I authenticate again, and click Proceed, and this will connect to Perforce, and we can see it's picked up the repository, so I can just change the name to Super Awesome Game. And when you create a new project in TeamCity, it also creates a new build configuration, and the build configuration could be for building a macOS game, it could be for building a WebGL game, and the build configuration contains one or more build steps, which I'll show shortly. But for this first build configuration, I'm going to rename this because I want this to be for building my macOS version of the game. So I've changed the name and click Proceed. And TeamCity has auto detection built in for detecting the types of build steps you might need based on the code that is inside of the repository. So it scans this repository in Perforce and it's detected that it's a Unity game. And because I have the Unity plugin installed in TeamCity, it suggested the Unity build step. And you can tell which plugins you've got installed if you go to the administration section and go to the plugins area. You can see a list of all of the plugins that are installed, and you can see Unity support listed here. And this is a JetBrains developed plugin. And if you want to install this on your own TeamCity server, if you just head over to plugins.jetbrains.com and search for Unity support, you can then download that zip file and upload it inside of the TeamCity plugins area. So jumping back to my super awesome game, we can see if I jump to the build configuration for building the macOS app, I can start to edit the configuration settings. Now, when this build is running, it's going to be producing an artifact, and that artifact is going to be the built version of the macOS game. So it's going to be a .app file. And I need to tell TeamCity that I want to zip up the contents of the folder where the macOS app resides and store that zip as an artifact inside of TeamCity. So on the build configuration settings, I've scrolled down to the artifact paths, and I'm telling TeamCity to grab the contents of the macOS folder and zip that up into game macOS.zip, and that will be stored as an artifact so we can download it or use it in subsequent build configurations. So I'll save that change. And then the next thing I want to do is add a build step, because we need to tell TeamCity what it needs to do in order to run the build. You can either do the auto detection, or let me just go ahead and add the Unity step manually. And there are only a couple of things I need to define on here. First of all, I need to tell it which method to execute inside of my game builder class. So all I need to do for that is specify the class name, which is game builder, and then reference the method name inside of my game builder class. So I can just copy the perform macOS build method and paste that in there. Don't do any brackets, just do game builder.perform macOS build. The other thing I want to do as well under the command line arguments, in order for TeamCity to see the output from the Unity CLI, I just do log file and a dash, and we'll save those changes. And then under the triggers, TeamCity by default has a VCS trigger. I want to delete this because I'll show you shortly I'm going to create a build chain or a build pipeline. So I'm going to be linking several build configurations together. And I want to have just one VCS trigger on the final build configuration in my build chain, because the way TeamCity works is if you define a VCS trigger at the end of the build chain, it will automatically trigger all of its dependent build configurations based on what the changes are or whether anything can be reused. So I'll delete this default VCS trigger. So now we've got the one build configuration for building the macOS version of the application. So I'll go ahead and create a second version of, a second build configuration. So if I jump back up to my project, I can click on the Create Build Configuration button. I'm going to choose the manual option because we already have a VCS route defined at the project level. And I'm going to call this new build configuration build WebGL. And click Create. And I can choose to attach an existing VCS route. You can see it's listed the Perforce repository that's defined on the root project. And again, it's going to auto detect the build steps. You can either wait for that or click cancel, and you can just add the build steps manually, which I'm going to do now. So I'm going to choose Unity again, and this time I'm going to do game builder, and I'm going to reference the WebGL build method. And again, the additional command line argument for log file. And then jump into the general settings of the build configuration. I need to define the artifact paths again, so I can just add in the location of the WebGL game, which will be under the build folder in a subfolder called WebGL. I'm going to grab the contents of that folder and add it to a zip file called game.webgl.zip. Okay, so we've now got two build configurations. This is going to actually generate our builds. So rather than developers running the builds on the individual machines, they can check in their changes and TeamCity will automatically build the game and also store the artifacts for future reference. And that's quite useful if you want to maybe replicate a issue in an older version of the game, or just share builds with your team. The final thing I want to do is deploy a WebGL version of a game to an external service. So I have a S3 bucket that's set up as a website, and I want to copy my WebGL files all the way over to S3. So the last build configuration I'm going to create is for the deployment of the WebGL game. So I'm going to call this the deploy WebGL. And because this is deploying artifacts, I'm going to choose the deployment build configuration type. Okay, and under here, I can go ahead and add some of the necessary configurations. The first thing I'll do is add a build step, and this is going to execute the AWS CLI to copy the WebGL files, the index page, and all of the assets for the game in order to run. I will copy all of that over to the S3 bucket. So I have the AWS CLI installed on my build agents that are used by TeamCity. So I can just go ahead and add a command line build step. And I can copy in some steps I prepared earlier. So I've got 3 items inside of this custom script. I've got the first one, which will sync the contents of the game folder, which I will add as a dependency shortly, and it will sync the contents of that folder over to the S3 bucket defined here. The second entry will actually remove the files that have a gzip extension, because I want to, or rather I need to, define a content encoding type on the gzip files, and this ensures that when the website that's being rendered on the S3 bucket is actually passing down the correct content encoding types for the gzip files. So I'll go ahead and save that. And one of the next things I need to do is define the VCS root again. So let me attach a VCS root, and I can just choose the project VCS root. I also want to define a trigger, and I'll choose the VCS trigger. So there are different triggers you can choose from. So if you want to do maybe a nightly scheduled build, you can do a scheduled trigger, but I'm just going to choose a VCS trigger. So whenever a change is detected in Perforce, TeamCity will detect those changes and automatically run a new build. The next thing I want to do is create my build chain, and this is also referred to as a build pipeline. And in order to create that build chain, you go to the dependencies section of a build configuration and you define its dependencies, so what this build configuration is dependent upon. And to define the build chain, I add the snapshot dependencies. So you can see I've got my super awesome game here, and I'm going to choose the build macOS and the build WebGL build configurations, and that creates the build chain, which can be visualized by clicking on the build chain link here. And because the macOS build and the WebGL build have no dependency on each other, TeamCity automatically figures out that those builds can actually run in parallel. So rather than waiting for the macOS build to finish before the WebGL build starts, those can be run in parallel, and that'll be handled automatically by TeamCity. And then we've got our final build configuration here that deploys the WebGL game, and that depends on both of these, but it's going to wait until the WebGL build is ready before it then deploys it to the S3 bucket. The last thing I want to do is define the artifact dependencies, because in order to publish the WebGL game, this build configuration needs to have a copy of the zip file that was created under that build configuration. So to do that, I need to define the build configuration I'm grabbing an artifact from. So I'm going to choose the build WebGL build configuration. I'm getting artifacts from a build in the same chain. And the artifact rules, I'm going to define the name of the WebGL zip file, and I'm going to automatically extract that zip file into the game folder. And that game folder is what we're syncing to the S3 bucket using the AWS S3 commands. So I'll click save on that. And then if we jump back up to the projects, we can see we've got my super awesome game. I've got my 3 build configurations. And if I click the deploy button, this will automatically run the macOS build, the WebGL build. And once those are both finished, that will then deploy the game, the WebGL game, to S3. So we'll wait for this to finish. It will take quite a few minutes for the first build, but we'll come back shortly when this is finished. Okay, so we've got the first version of the game built. I manually triggered this in the TeamCity UI, and let me show you what's actually been produced and recap what we've done. So under the game, because a build has now been run, we can go to the build chains tab and see our first build chain. We can see that all 3 build configurations were successful, indicated by the green check mark. We can also see which build agent each of the builds was executed on. And if I go back to the project itself, on the right hand side of the screen, you can see the artifact icons, and that indicates that there's an artifact associated with this particular build. For the macOS version of the game, if I download this zip, I'll just save this onto my desktop. And if we open up this game, this is what the experience looks like on a desktop. So we've got the player, you can see the tokens that can be collected. But it'd be good to make this game a bit more interesting. So what I'm thinking of doing is actually changing all of the tokens that we see. So all of these diamond-shaped tokens that you can collect, I'm thinking of changing those for TeamCity tokens. So let me close this game, and we'll go back to the Unity interface. Now I've already created an asset or a sprite that will be used for the TeamCity token. So if I go to my PNG image I prepared earlier, we can see I've got 15 versions of the TeamCity logo that I've added into a single PNG file. And each of these TeamCity logos has a gradually increasing in size flash or just a random graphic, just so I can use this for the purposes of an animation. So you can see it gradually increases in size and then decreases, and this will be looped inside of Unity. In order to add this sprite inside of Unity, if I go back to the project and go to the sprites folder, I'm going to add the image in there. I can do this by dragging and dropping the image over, and we can see down here we've got the TeamCity token image. Now in order to configure this sprite, first of all I need to configure a 2D sprite editor in this project. So under the window menu, if I go to Package Manager, what we can do is browse the available packages and choose their 2D sprite editor. So if we just choose 2D Sprite, install that, and that will enable the editor for this project. Okay, so the 2D Sprite editor has been installed, and if I go back and click on my TeamCity token PNG image again, on the settings for this sprite, rather than it being a single image, I want to choose multiple because this PNG contains multiple sprites. I can then click on the Sprite Editor button, and this will launch the Sprite Editor. And now we need to tell Unity what the different boundaries are for each of the images inside of this sprite. So I'm going to choose Automatic Detection and then click the Slice button, and you can see it's added borders around each of the sprites. So if I click on Apply, that now creates our that gives us our animation that we can use inside of the various tokens in the game. And if you click on the expand icon here, you can see the different frames inside of this sprite. And in order to apply this to my game, what I want to do is in the hierarchy, if I go to tokens, and if I select one of the tokens, you can change its properties, you can change the sprite that's being used. So I'm going to select all of my tokens. And under the sprite here, we can select the initial sprite that is shown. And I'm going to search for my TeamCity token and just choose the very first frame. Now this is quite a large token in comparison to what was there before. So let me scale this down to 0.5 on both the X and the Y axes. And then the next thing to do is to set up the animation. And in order to do that, we can go down to the idle animation on the right hand side here, and you can define all of the different frames that will be used for this animation. So I have a total of 15 frames, so I'm going to define 15 here, hit enter, and that creates the extra elements. Now I'm not expert in Unity, so I'm not sure if this is the quickest way of doing it, but if I just drag and drop the different frames from the project here over to the inspector, that allows me to define the animations. So let me just select the tokens again. And I can drag and drop the sprites I want to use. Okay, so now we've defined all of the different elements for the animation. So I can go ahead and save that. And under the version control section, we can see that there are a few modified files. We can also see the scene has been updated. We can see the TeamCity token.png file that I added into this project. So now that I've saved the changes, I can right click and submit those changes. And I'm going to say I've changed the tokens and then click submit. And if we go back to the TeamCity user interface, after a few seconds, we will see a pending change detected by TeamCity, and we can see that shows up here. And we can actually see all of the commits that have been detected. And now both the macOS and the WebGL build is running. So if we click on the link here, this will actually take us to the running build, and we can preview the log file as the build is running. So if we go to the build log tab, and this is a nice rich build log, it groups all of the parts of the log by the different sections. If you have multiple build steps, you have multiple areas of the build log that you can expand and collapse. And we can monitor all of the different steps if we wanted to. Under the Changes tab, we can see the full list of changes. If I want to see which files were changed, I can click on that and see the changes. If there are file types that you are maybe text-based and you want to compare them, you can actually click on the files and see a side-by-side comparison. For this one, it's not so useful, but that capability is there if you want to compare the before and after state of a particular file. So we can see, if we jump back to the project screen, we've got the macOS build that has completed successfully, the WebGL build that's completed successfully, and I've also deployed the WebGL version of the game. So first of all, let's download the new version of the game. So if I go to Artifacts, and let me save this new version of the game. Again, I'll save that to my desktop. And we'll load up version 2 of this game. We need to do this twice because it's not a verified game. And now when we jump back, the game is much more interesting because we've now got TeamCity tokens that we can collect rather than boring diamond-shaped tokens. So this kind of shows how cool TeamCity is, how quick it is to configure a Unity game, and how you can make a quick change inside of the Unity editor. Obviously, I'm not a gaming expert, but this just kind of shows the flexibility that you have when you have something like TeamCity to automate your builds. And then lastly, we've got the WebGL version of the game, which has been published to my S3 bucket, which is running as a website. So if I navigate to that game in the browser, we get the exact same experience only inside of my browser instead. And I can go ahead and collect more TeamCity tokens, or I can die because I'm not very good at gaming. So that's how you can build games inside of TeamCity using Unity and Perforce. I hope you found this session interesting. Feel free to ask any questions and be happy to help. Thank you.
Welcome back. What a great talk.
Indeed it was. Yes, I agree with you 100%.
Actually, I have to say hats off to Daniel, not only for getting the Unity knowledge, which went perfectly well, even though you're not an expert, but I mean, it was great. But then again, also putting everything together into one, from the Perforce integration, from build pipelines, AWS upload, S3, hats off.
Yeah, I totally agree. I mean, from one side, it's just a fun little talk with building this fun little game. On the other side, there's so much pieces involved there. Yeah, as you said, Perforce, Unity integration, AWS. Yeah, that's a pretty complicated, but also very useful and very, I think, close to real life setup.
And I think it's a bit of a shameless plug, but the funny thing is games always have something special about them being built, even if it's just a small jump and run or a tiny jump and run. But even we had these interviews with game companies like EVE Online or World of Tanks, for example, and it's always super interesting how games in the real world are being built, what sometimes crazy build pipelines they have, how complex it is, until you, at the end, drive a tank and, drive through some walls, basically. So have a look at them again on our YouTube channel.
Yes, absolutely. Back to the quiz answers, are we?
Back to the quiz answers, but I'm a bit disappointed because you mentioned Kotlin DSL, but we didn't see any Kotlin DSL in the code.
Right, but not on this version. So as Daniel has promised me, next version of this demo will include Kotlin DSL.
Okay.
But I have very good news for you, Marco. You know why? Because you guessed perfectly correctly the year and the version of TeamCity where Kotlin DSL was released. That was in 2017, the version number 10.0. Right. And 10.0 was the version after which we have switched to the year dot number versioning system. So this was guessed correctly by you. Also, I just want to just a big shout out to Dylan in the chat on YouTube. Dylan has been our longtime customer since the version 3.0, and he's getting all these quiz answers correctly. So yeah, shout out to Dylan.
Yep.
Thanks for trusting us, the product and the team. So next up is this. I think this is the most complicated screenshot of today. And this is?
Right. I had a brief look. I mean, it's easy because it says create new cloud profile.
Yeah, I left it in just on purpose.
Which means it's about, cloud profiles, meaning you can basically configure how your agents should be spawned for your builds, in which cloud, and a couple of other options.
Right. Yeah. So as you said correctly, cloud profiles are there to help you run your builds in whatever cloud you want, to help you manage the build agents automatically. If there's more builds in the queue, the TeamCity will be able to create more, spawn up, launch, create more build agents. If there's no builds in the queue left, it will shut them down. Basically leaving your cloud resources free of additional costs. Runs with AWS, VMware, also with additional plugins with Google Cloud, Azure, you name it, basically.
Yep.
So what's your guess? When was this feature added to TeamCity?
It's tricky. I'm gonna say, for whatever reason, I'm gonna say 2018.
2018. So,
Yeah.
Okay.
For whatever reason, I don't know why, but it's a I don't know. I'll just say 2018.
2018. We'll take this as a guess. Add your suggestions in the chat. Meanwhile, and now I promise you that this feature will be mentioned in the next talk.
Right. Because the next talk is going to be not just talking about configurations, but actually showing integrations with other third-party, let's say, tools for now. That's the name of the talk, Supercharging Your CI integrations, and given by David.
Let's watch and listen to David.
Let's watch and listen. Enjoy.
Hi, my name is David Stewart. I'm a sales engineer with JetBrains TeamCity. And today I'm going to walk you through 3 integrations to help you bring your CI to the next level. One of TeamCity's strengths is that we offer a lot of out-of-the-box functionality to help you integrate your CI into the other tools that make up your SDLC tool stack. So today what I want to do is focus on just 3 of those integrations specifically. What we'll do first is I'll give you a quick overview of the integrations we're going to talk about. So if you're watching the recording of this video, there'll be timestamps at the bottom. You can go ahead and just skip ahead to what interests you most. So taking a look, Cloud Profiles is going to be our first focus area. Cloud Profiles is an integration between TeamCity and your cloud computing environment. So that could be something like AWS, Azure, Google Cloud, Kubernetes, or some others. And basically what it allows you to do is spin up and scale your build agents in those environments on demand. So at a basic level, what's happening is a build gets triggered in TeamCity, and TeamCity is going to communicate with your configured cloud profile and spin up a build agent which can run in that environment. So these agents get set up in these cloud environments as AMIs or images or virtual machines, and TeamCity is going to handle the full licensing and lifecycle of that build agent. And what this can help prevent is a situation where your agents are sitting idle for hours at a time because they just can't run any of the builds that are sitting in the queue. And this can allow you to get some better utilization out of your existing licenses and also ease up on some of the management efforts that are required to manage, tens, hundreds, thousands of persistent agents. The second feature we're going to take a look at is integrating and embedding HTML third-party reports into TeamCity. We're going to do this without having to install third-party plugins or do custom coding. We're seeing that a lot of tools, including security scanning tools, testing tools, etc., they offer the ability to create these really rich HTML reports. And what we're going to do is we're going to embed those HTML reports into a TeamCity build tab so your teams can more easily review them alongside of the unit testing reports and a bunch of the other integrations that are already available inside the TeamCity UI. So we'll walk through a sample setup there. The last thing we're going to do is we're going to take a look at some of the available integrations between TeamCity and your IDE to do interesting things like running personal builds and also more mundane things like viewing the build status. So if you haven't installed the TeamCity plugins into your IntelliJ-based IDEs or Visual Studio or Eclipse, we'll show you how to do that and how to get up and running with that integration. So those are the core focus areas today. But as you probably know, TeamCity has a large number of integrations with other tools that make up your SDLC. So if you do have specific questions, please go to our website and get in touch with our team. We're happy to answer any questions you have. And with that, let's go ahead and get started with Cloud Profiles. So let's get down to basics. Cloud Profile is a collection of settings which allow TeamCity to start virtual machines or images in a cloud provider that can act as a TeamCity build agent. We support a number of different cloud providers, including AWS, Kubernetes, and VMware vSphere, which are all supported out of the box. And we also support Azure and Google Cloud. These are JetBrains developed and supported plugins, but you will have to download and install them from the JetBrains plugin marketplace. Cloud profiles can be configured across your entire TeamCity instance, or you can configure cloud profiles at an individual project or sub-project level. So this gives your teams the ability to control which projects have access to which build resources. Before we talk through the configuration of a cloud profile, let's quickly review why a customer might use them and some of the benefits that they provide. From a licensing perspective, I know nothing is more frustrating than watching your build sit in a build queue while some other permanently connected agent sits idle that's not able to run your build. Cloud profiles can streamline some of this licensing in TeamCity so that when a build is triggered, TeamCity is going to spin up an agent that you know has the appropriate requirements to run the build. It's going to license that build agent, and then importantly, it's also going to release that build agent license when the build finishes or under a set of parameters that you define. It costs money to keep these build agents alive, especially in a cloud environment. So TeamCity allows you to specify a number of termination conditions so that you can determine if you want those agents to be single use, shut off after a single build, or shut off after some sort of period of inactivity. And that's useful because I know we could all use a lower bill from our cloud providers. Another major benefit is that if you're using cloud profiles with AMIs or images for your build agents, instead of managing tens or hundreds of individual build agents, now you can only manage one agent image or maybe a handful of agent images if you have different requirements. So if you have software that needs to get updated, you only have to perform that task once. If you're already using build agents in other cloud providers like AWS and Azure, then using cloud profiles is really a no-brainer with TeamCity. So let's go ahead and take a look at how you actually configure them. Our first step is going to be to create an image based on the TeamCity build agent software that TeamCity is going to be able to connect to and create multiple VM instances of. I'm going to be running through this example in AWS, but functionally the process is going to be the same whether you're using AWS, Azure, Google Cloud. It will be a little bit different if you are running your build agents in a Kubernetes cluster. And that won't be covered in the video, but there is good documentation on our website for this use case. So our first step in AWS is to create a new instance, which we're going to base our image on. You can create a cloud profile for any different OS or architecture type you need. And in fact, you may have different cloud profile images for your different development projects based on the building requirements for these projects. So I've gone ahead and I've already created an instance. The instance type isn't really important. What we want to do is we want to make sure that the TeamCity build agent software gets installed on this instance before we create the image. So if we go ahead and log in here, we can see that we've already installed the TeamCity build agent software. And importantly, you want to configure the build agent software so that it starts automatically. That way, when TeamCity is spawning a new instance of your build agent, it can connect to your TeamCity server and be ready to go to start building. Once we've created the TeamCity build agent instance, we're going to go ahead and we're going to create an image based off of that instance. You can do that through right-clicking on the instance name, going down to Image and Templates, and clicking Create the Image. This is what we're actually going to point to in TeamCity Cloud. There are some other intermediate steps for installing the build agent software, making sure it auto starts. All of that information is available in the documentation. Once you've configured the build agent images or AMIs that you want to use for your project, we can navigate back into TeamCity and configure the cloud profile. As I mentioned earlier, you can configure these cloud profiles across your entire TeamCity instance, or you can configure cloud profiles at an individual project or sub-project level, which is what we're going to go and do here today. So we're not going to navigate into our project and into our project settings, and then about 3/4 of the way down on the left-hand menu, you'll see an option for cloud profiles. We'll navigate into there, and we'll click Create New Profile. The first thing we want to do is select our cloud type. You'll see I have a few extra plugins installed in here, but we'll select Amazon EC2. We'll go ahead and give this a profile name, and now we can begin setting some of the termination conditions for how long we want these agents to live. The first thing we can set is the terminate instance idle time. This is going to default to 30. This is basically going to say if we see a build agent which was spun up with this cloud profile sitting idle for 30 minutes, go ahead and shut down that agent. We can also specify other termination conditions, for example, stopping after a certain amount of work time, or if you want these agents to be single use, spin them up, run the build, and kill them. You can go ahead and terminate the build agents after the first build completes. We'll go ahead and authenticate with our access key ID and our secret key, and we're also going to specify which region we want these build agents to be spun up in. You can specify limits for how many instances of these build agents a particular cloud profile can spin up. So if you need to control the resources that a specific project has based on how many build agents you have your license for, you can do that here as well. We'll go ahead and we'll check the connection, and then we can add our actual agent images. You can add multiple images for a single cloud profile, and I'll show you some of the settings you can specify here as well. So if we go ahead and we click on the Add Agent Image box, the first thing we're going to do is give it a name and a source. The source is going to be that AMI image that we created earlier, so we'll go ahead and select that. You can select all of your, these are Amazon specific settings here, your key pair name, your VPC subnet, your security group. And again, here you can set the max number of instances that this specific image is allowed to spin up inside this project. I will click on the advanced settings just to show you some of the additional features that are available. Some of the more interesting features for AWS specifically is we do allow you to use spot fleets or spot instances. If you're using just a regular image, you can use a spot instance. You can set the bid price for that specific image. Regardless, you will need to also specify the instance type, what size instance you want the agent to run on. And then if you want, you can also add these agents to a specific pool. So if you're already using agent pools to manage your build agents in an effective way, this is another way to just add those agents to a pool. So we'll go ahead and click Add, we'll click Save, and we're good to go. The last thing we'll do is we'll go ahead and run a build with our new cloud profile enabled. So if I navigate back to the project level, we will go ahead and just run a sample build of this pet clinic application. And then if we scroll up to the Agents tab, we can see that build agent spin up, get provisioned, get licensed by TeamCity, and then run the build. If we stuck around a little bit longer, we could also see the agent get terminated once it reached matched whatever termination conditions we set, and then that agent license would get returned back to the pool to be used by another cloud profile or for whatever else you need that agent license for in TeamCity. Next, let's focus in on how you can add third-party reports into your TeamCity instance seamlessly. So a lot of tools nowadays are generating these reports that we may want to see inside TeamCity without having to go to some other portal or some file directory somewhere. And the reports can come from just about any source, but we're frequently seeing customers integrate security scanning reports, reports from unit testing suites, visual regression testing reports, code coverage reports. There are really endless possibilities here. What's important is that your tools are able to generate an HTML report that could be one HTML page, a set of HTML files, and then we can bring those reports directly into a project or a build tab. There's no coding required. There's no plugins you need to install. This is all available out of the box. So there are three basic steps to this process. The first thing we need to do is we have to generate the report as a part of a build configuration. So this process is going to vary depending on the tools that you're using and the reports that you're trying to generate. In the example here, I'm going to be generating a code coverage report, which gets run when we execute one of our Maven goals. But your tools may rely on some sort of command line call or some flag in your command line build steps. It could be an API call, or there may be some other way you're generating your reports. The important thing is that your build configuration generates the reports and is able to get pulled onto the TeamCity build agent. The second step is we need to make sure that TeamCity knows where to fetch this report, and the way we do that is by configuring an artifact path. So in our build configuration where the report gets generated, we're going to navigate into general settings, and then if you haven't already, you'll want to specify what that artifact path is. In our case, we have a target folder that gets generated. That's for all of our build artifacts. But it also includes our artifacts for the code coverage report. It gets generated in this site subdirectory. So you'll just want to make sure that at least the high-level directory folder here is specified. Once we've done that, we can navigate back up into the project settings, and the third tab down on your project settings is going to be this reports tab. Here we have two options. We can generate reports, a report tab that's going to appear at the project level, or we can generate a report that's going to appear at an individual build configuration level. So this is just determining where you want that tab to exist. We'll go ahead and create one at the project level. We'll give this new tab a title, and then we're going to tell TeamCity where we're fetching that artifact from. So that's going to be which project and build configuration are we getting the project from, and then importantly, which version of that artifact do we want to display. We can select something like the last successful build. You may want to choose the last pinned build, or you can be much more specific. If you have builds that run and get a tag added, you can run a build and grab the report with a specific tag. We'll go ahead and use last successful here. We can also specify a branch filter. So you may not want to have a code coverage report displayed for anything other than your main branch. You want all of the other development branches. You don't need to see the individual code coverage reports there. That sort of behavior is up to you. You can use the little magic arrow icon to show you all the different branches that are available for that build configuration. The last thing we're going to do is specify the start page. Because it's an HTML report, we just need to put the start page here. Even if your report is generating a bunch of different HTML pages, that's fine. All we're doing is we're going to point to where the start page for, in this case, the code coverage report exists. So we'll come into the target, into the site folder, and we'll select index.html. It'll change the path, and we're good to go. We can go ahead and click save. So if we go ahead and run a new build, we can now see this custom tab inside of our project level. So we'll go to Spring Pet Clinic, and then here you can see, yes, we have our new custom tab, which is displaying our code coverage report. This is fully navigable. You can click in and out, move between the different aspects of the HTML report. Let me show you a couple of other interesting ways we're using this internally here at JetBrains. I'm going to go to our public TeamCity.JetBrains server, and we're going to take a look at the Ring UI project, which is just a collection of our UI components that developers can use if they're developing third-party plugins, and then we obviously use it internally as well. One component of the Ring UI is we generate a storybook, which is a large HTML page where you can interact with the different UI components. And we actually display a copy of this storybook inside of the TeamCity UI. So when a build runs, if we want to see if anything got generated that looks a little bit weird, we can do that directly inside of the UI at the project level here. A more interesting use case is our visual regression testing. We use a testing suite called Hermione to run our visual regression tests. And then as a part of that visual regression testing, we have a custom report in our build configuration tab that's going to output the full Hermione visual regression testing report here. Much like the code coverage report, you can interact with this. You can view the skip tests, the failed tests, etc. It's up to you how you want to display the results in here. So just two interesting use cases. If you have your own interesting use cases, we'd love to hear about them. Please feel free to get in touch with us, share it, and we'd like to see how we can improve here. The last thing we're going to look at today is TeamCity's various integrations with IDEs. TeamCity supports IDE plugins for most of the IntelliJ platform based IDEs from JetBrains, so that includes IntelliJ, PyCharm, WebStorm, Rider, and the others. We also develop and support plugins for Eclipse and Visual Studio. The first thing we need to do is install the plugin into our IDEs. For IntelliJ-based plugins, you can do this from plugins.jetbrains.com. Just search for TeamCity, and then from the TeamCity plugin page, there's actually a one-click install in the top right corner. It'll open up a dialog inside of your TeamCity IDE, which will allow you to install the plugin. It may require an IDE restart, just as a heads up. Once the plugin is installed, it's going to add a new menu bar at the top here for TeamCity. We're going to go ahead and log in to our TeamCity instance. So go ahead and give it the URL, specify your password and username, and click OK. And once you log into the IDE plugin for the first time, I recommend you configure your visibility and notification settings by clicking this Configure Shown Projects icon on the left-hand side. That's going to open up TeamCity in a tab in your browser, and you're actually inside of your TeamCity profile right now. So from here, you can configure things like your notification rules and your visibility settings. You can see I have a notification rule already configured in here. Basically, this is just showing projects and build configurations related to Spring Pet Clinic, and then I am letting the IntelliJ IDE show in IDE notifications when a build fails or a build is successful for this specific project. So let's take a look at some of the things you can do inside of the TeamCity plugin. Some basic functionalities are available in here. You can view your projects, the build configurations for those projects, and the latest status. You can see if the tests have passed, if the tests have failed. You can also view the build data directly in the IDE for things like the build log. One of the more powerful features of these IDE plugins is they allow you to execute a remote run or a personal build of your changes in your IDE. So let's say you're making some changes to your code base. You may not necessarily want to commit them to the code base yet, where a regular build would be run. What we allow you to do is execute these remote runs. These are personal builds that happen on the TeamCity server and build agents, but they're only going to be visible to you. So you can run your builds, your changes in peace without other folks eyeing and seeing what's going on. If you select the remote run feature, it's going to show you a list of the changes that exist in your workspace right now. You can specify a commit message. This is just going to be shown in TeamCity. We're not actually committing any source code here, but we are notifying TeamCity what the changes are that are about to be run on this personal build. We'll go ahead and click Remote Run in TeamCity, and we're going to be given the option to select which build configuration we want to run for this project. It's automatically identifying the various configurations that may be suitable here. I use this Pet Clinic application a lot, so I have a few demo configurations that I could also select to run this on. We'll go ahead and click OK, and then if we navigate back to TeamCity, you'll see something interesting on the projects page for Pet Clinic. You'll see the regular builds that we've run in the past from our cloud profiles or from our other build runs, but you will also see a new icon for the running build, with this little person icon, this is your personal build. So anything that happens here is only going to be visible to you. Only you can view the changes, the passed or failed tests, etc. So let's give this a minute to finish running. Okay, through the magic of video editing, our personal build has finished, and it looks like we have a build failure. We see the little notification in the bottom right-hand corner. We can go ahead and view the full build configuration run inside the browser. That's going to pull up the personal build, and you can navigate through this the same way you would a regular build in TeamCity. But we can also view the details of this build failure inside of the IDE. In this case, we had 2 tests that failed. We can navigate through these tests, try to figure out why they failed. And another interesting feature here is if we right-click on these tests, we can run these tests locally because they're integrated with JUnit. So TeamCity is able to detect them, and we can just run these tests locally without having to run the full test suite back in TeamCity. So some more nifty features for the IDE integrations. TeamCity IDE plugins also enable you to execute pre-tested commit or delayed commit workflows. In a pre-tested commit workflow, you submit your code changes to be executed via TeamCity remote run before the code actually gets committed. So if your changes pass and you have a green build with that remote run, your changes are automatically committed to your version control system. With this type of workflow, broken code never enters your version control system, which can be a huge advantage for some development teams. There's some limitations depending on the IDE you're using and which version control system you're using. So check out the documentation on pre-tested commits if you're interested in learning more. So that's it from me. If you have any questions about what you've seen here today, definitely feel free to get in touch with us via our website. There's a lot more to discover. TeamCity offers a huge number of integrations with other tools that make up your SDLC tool stack. So here's to lots of green builds and happy building.
Welcome back, and thank you, David. The interesting thing for me is about these integration features that TeamCity has so many different features, and essentially sometimes people just don't know about them or how to use them, what to use, and what should they be using, and even stuff like the IDE plugin. I mean, I've been using it in the past, and I was surprised that many people didn't even know about it, kind of. But it's just helpful little things which you can give a try and make your daily life a bit easier, I guess, when it comes to development.
Yeah, right. Well, this is why we're here today, right?
Yeah.
Part of the reason we're here today.
Yeah.
Hopefully talks like this help some of the folks to figure them out and try out some new parts of TeamCity that they've never tried.
Yeah, give it a try.
Also, they can save some money with cloud profiles, right?
That's right.
I promised that David will cover this, and he did.
Yes, he did.
Cloud profiles can indeed help you optimize your costs of running some of the builds in the clouds, either your own private clouds or public clouds, whatnot. So back to the quiz answer. You said your guess was
2018.
That cloud profiles were released in 2018. I'm sorry to break it to you, but they were released in 2012.
What?
Yes, the first cloud profile feature was released in the version, I believe, 7.1 back in 2012. Back then, the AWS EC2 based cloud profiles were supported. The feature was, of course, developed more and more over the next years. But yes, this is where it was initially released.
I have to go into hiding now. Sorry, team. Sorry about that.
Yeah, no problem. I have more. We have one more talk to go, right?
Yes, one more talk to go.
I have 2 more boards to share with you.
Okay.
So
I'll give
board
you a
number
hand.
1. It's a pretty small one. Let me show it
right
to our viewers. So there's kind of a lot of things happening here, right?
Yeah.
So can you explain what you see here?
What I see is essentially there's a specific branch called net213 being built.
Okay, that doesn't matter. I'll give you a hint.
Right. The time left roughly 6 minutes 50 seconds.
Okay.
Test passed already 128. So it's basically an overview of a specific build. that you can see in the UI, and it could be that it's the new UI.
Yeah, you're very close here. So 2 things you mentioned is that, first of all, you could see in real time how much time is left, and you can also see in real time that the progress bar in this case is green, which means there are no failures at this moment. You could also see at real time how many tests have passed. And in our example here, all the tests are green. That means that none of them have failed. But if you would have had failed tests, you would have seen that some of them have failed, even until the build is finished.
Okay.
So we're talking here about the real-time tests reporting, test progress.
And now you want a number again.
Yes, I want a number, either a version or a year, and then I have a second one for you.
I'll say 2010.
2010.
For whatever reason, yeah, because I was so off with cloud profiles, and I remember the real-time stuff being in. Okay, let me make it 2011. 2011.
2011.
Yeah.
Okay. You could also take your guesses in the chat, and if you could help me hold this, please.
Yeah, sure.
I have a second one for you. So the second one would be. Let me just quickly hold it up here. So this is a graph of sorts, right? A diagram.
Yeah, it looks like it could be the test history overview page.
True.
Because I can see there have been 999 runs, okay, specifically, and only 28 failures. The graph is essentially how long did the past, test runs take.
Yeah, that's true. Yeah, that's what it is. It's the test history page. Shows you the history of the previous runs of a specific test. Shows you the statuses of this test, the how long it took, which agents they run. This is not the whole screenshot of the whole page. But you can figure out a lot of insights from this graph. So what's your guess for this one?
2016 or 15.
Okay, so 2011 for the real-time test statuses, and 2016 for the test history page.
Yeah,
right.
Yes, let's make.
I think this is good enough to go into the next talk. For everyone watching, please feel free to take your stab at when these 2 features were released. And our next talk is
we're going to talk about tests and TeamCity. So if you're excited about tests, because everyone is talking about tests, but also everyone has red tests, essentially failing builds. Evgeny is going to tell you what to do with your tests and your TeamCity builds.
Great. Let's watch it.
Enjoy.
Hi. Now we're going to talk about automated tests. You probably know what automated tests are. They are code that checks that other code is executing properly. But what can TeamCity know about your automated tests? Let's find out. All examples provided will be in Kotlin, but what I'm talking about applies to all technologies and programming languages. All examples will be provided in a single repository, and the link to this repository will be provided in the video description. So here we have a simple test written in Kotlin using Unit 5. This test checks that 2 is equal to 1 plus 1, which is true, so this test will pass. But in this test, we check that 2 is equal to 1, so this test will fail. We also have a couple of more tests. For example, this test executes for 3 seconds. Now let's see how it looks in the TeamCity UI. So here we have a build configuration overview page, where you can see that we have a number of builds. And for each build, TeamCity reports how many tests have passed and failed. So TeamCity actually understands each individual test. Now let's go to the build overview page. Here you can see a test tree. TeamCity actually understands to which package this test belongs, and also in which classes the test were executed, as well as each individual test. If we want to want more about tests, we go to the Test tab. Here by default we see all the failed tests, but we can also see successful tests, as well as all tests. Also in this table we can see the test duration, so how much time it took to actually execute a test. And we can sort by this duration. For example, we can find what is the slowest test in our source code. And then we maybe could try to optimize it. Now, let's say that you have a build that executes for a long time, 10, 20 minutes, maybe even an hour. It would be cool if we knew which tests have failed, even though the build is still running. That's what TeamCity can do. Now, as you can see, TeamCity already knows that this build will fail even though it's still running. TeamCity even knows which tests were executed and failed at this time. And we can already work with tests that were executed. We can go to the Test tab and see which tests failed. So, as soon as a single test fails, TeamCity already knows, and for example can send a notification to Slack or email, and you can start fixing this test right away. Also here we can see that this test took 15 seconds to execute. Let's try to investigate. Maybe this test is too slow. We can go to the test history and see all of the time it executed. We can also see how much time it took to execute. Seems like it always takes 15 seconds to execute. Now, you might have a test that sometimes fails and sometimes succeeds, even though you didn't change anything that relates to this test. Such tests are called flaky, and here we have a simple example of such test. It generates a random boolean, and if this boolean is true, it compares 2 to 1 plus 1, which is true. But if it's false, it compares 2 to 1, which is false. So in this case, this test will fail. This is by definition a flaky test, because it fails on some random condition. Now let's see what TeamCity actually understands about this test. As you can see, TeamCity marks this test as flaky. And it also explains that the test status changed in the build without actual changes to the source code. We can again go to the test history to try to investigate this test. And we can see that in this case it succeeded, but then it failed, even though we didn't make any changes to the source code. Thus, by definition, this test is flaky. So now we can compare these two builds and try to understand why it succeeded here, but failed here. Maybe it was the edge it was executed on, or maybe it was some random condition, like in our case. Now, let's say that you have a failing test and you want to try to investigate it. You might just copy the test name and go to Slack and write it to someone that this test is failing. But that's not really scalable. You might have a team and might want to communicate to each member of the team that someone is investigating a test. So, TeamCity provides what's called investigations. You can click Assign Investigation and select to which member of the team you assign the investigation. For example, in this case, it will be me. You can also tell TeamCity to resolve this investigation automatically when the test is fixed. And we will not mute the test, so if it fails, the build will still be red. So now you can see this icon next to the test name, and everyone on your team will know that someone is investigating this test. In this case, it's me. Now, maybe you didn't manage to investigate why this test is failing, and you want to reassign it to someone else. You can do that simply here. And now someone else is responsible for fixing this test. You can also go to the investigation history and see who was investigating this test at which time. Now, what if you want to investigate a flaky test? In this case, you can't fix it automatically when the test is green, because the test is green and red on random. In this case, you can assign investigation, but tell TeamCity to resolve this investigation manually, so it won't be fixed automatically when the test is green. So you actually might have different builds that execute the same test. For example, it might be a build on Windows or build on Linux. In this case, TeamCity is smart enough to understand that the test is the same and actually assigns the investigation in all builds at the same time. Now let's try to fit this test. So to fit this test, we can simply compare 2 to 2 and not to 1. So now we have a new build in which only 3 tests are failing, not 4, so we fix the test. We can go to the previous build and see that the test is fixed, but investigation is still there, because TeamCity is smart enough to know that in this build, this test is still failing. We didn't actually run a new build in this configuration. So the investigation is still here. Let's run a build in this configuration too. So now we have a new build in this configuration where we also fixed the test. And now if you go to the previous build, we can see that this test is fixed and there's no investigation there, because TeamCity understands that this test is fixed in all builds, and now we can fix the investigation automatically. Now let's imagine that you want to add additional information to each test. It might be a statistical value or a screenshot that your test takes. In TeamCity, it's called metadata. If your test has a metadata, this icon will be shown. You can click on it and see the metadata of this test. In our case, you can see it's a screenshot, some numeric value, and even a Gradle HTML report that we can view from the UI. Now let's see how you can actually provide the metadata. To provide the metadata, you simply need to post a magic message to the standard output, and TeamCity will do the rest. These magic messages are called service messages. They have to start with 2 hashes and TeamCity. And then you specify which service message you are posting. In our case, it's test metadata. In this line, we post the metadata with some string value. And in this line, we post a number specifying type number here. On this line, we post the HTML file. You can see we specify the type artifact here. In this case, we want to publish the new image, so we first have to publish it as an artifact so TeamCity actually stores it, and then publish it as a metadata, specifying its type image. So the metadata might be useful if you want to add additional information for your test. For example, it might be a screenshot testing where your test takes a screenshot, and then if it fails, you can see the screenshot and actually understand why the test failed. Now imagine that you're working with technology that TeamCity doesn't support out of the box. For example, it might be a test runner or a different language that TeamCity doesn't know about. You can still publish tests via source messages as we've seen before, and TeamCity will understand that it's a test. A simple test might look like this. We just say that the test has started and provide its name. And then we say that the test has finished and can also provide its duration. We can also provide some additional information, like the error message, or even the stack trace. Let's see how this actually looks in the build. So here we can see the failed test, its error message, and a stack trace we reported. And you can also see that we have a successful test with the duration that we provided. Now let's talk about code coverage. Code coverage is a metric that shows how many classes, methods, or lines your tests are actually covering in your code. Let's look at the simple class. It has a simple method that if the flag is true will return 10, otherwise it will return 20. And it has a method that we will not cover by tests at all. So here we have a test that executes the method passing the false value. So again, this line will be covered while this one will not. And you can see the idea actually showed this. So the red one means that this line is not covered by the test, but this line is. Now let's see how it looks in TeamCity UI. If your build provides code coverage, TeamCity will show the separate code coverage tab. Here you can see the overall coverage summary by classes, methods, and lines. You can also see a more detailed report where each class is shown. Here you can see that in this class 3 lines are covered out of total of 5. And this class is not covered at all. Now let's try to cover all our code by tests. Now we have a new build with a new test that covers all of our code. So you can see the code coverage is complete. You can also configure fail conditions. For example, you might fail your build if the code coverage is less than 100%. As you can see, this build is red, exactly because the percentage of line coverage is less than 100. But this build is green because we covered all of our code by tests. You can also configure different failure conditions. For example, you might not be as strict as me and only configure 80% of code coverage, not 100. You might also compare the code coverage with the code coverage from a latest successful build and say that if it's less by at least 0, so it's less, then we failed the build. So this way you make sure that your code coverage never goes down, only goes up. As you can see, TeamCity supports a lot out of the box, but you can also extend this functionality by writing your own plugins, for example, supporting new languages and frameworks. There are also some advanced topics we didn't discuss. You can find out about them in our documentation and blog posts. All links will be provided in the repository. Thanks.
Right. Thank you, Evgeny, and welcome back. That was, I think, a great talk because tests are so essential to the CI pipeline. And the first time I saw, for example, the flaky test feature, I was like, what? I can automatically see the flaky tests and that sort of stuff, test history. Again, something that not many people really dig into, but it really does help having all these insights available. And hopefully, a feature I'm waiting for is hopefully it's going to land soon, where we can automatically split tests basically and parallelize them.
Yeah.
Hopefully that's coming soon. But again, I mean, in the end, yeah, tests. I don't know what to say.
Yeah, I think, well, test is part of the reason the CI as a concept was brought to life, right?
Yeah.
Running tests automatically, running them often on either on every commit or on like a group of commits. That's a core functionality of any CI server, I believe.
And just a shout out, we just saw in the chat, some user, I forgot the name, mentioned what a cool feeling it is to get these real life test insights and already push a fix while the old build hasn't fully finished yet. And that is essentially the spirit, that we try to
Right, yeah. That's the power of the real-time test results that you can get without having to wait until the build is finished.
Yeah.
Okay, back to the quiz, right? So before the talk, we had two questions and 2 screenshots. Basically, one is the test history.
Right, test history.
So you said 2016.
16.
You're a little bit off. I'm sorry. It was 2009.
Oh.
When it was released.
Right.
TeamCity 4.5.
4.5.
Yes.
Okay.
One of the earlier functionalities in TeamCity.
Okay.
And then the second one.
Let's see if I'm
okay. So the real-time test results.
2011, I think I said.
You said 2011.
Yeah.
The correct answer is TeamCity 1.0, 2006.
All right. Okay.
As I said, tests are core to not only TeamCity but also to CI in general. And TeamCity has been, I guess, one of the first maybe CI tools that was that brought this functionality and was allowed developers to see the results of their tests live from the very beginning. Isn't that cool?
It is very cool, but also I feel a bit of shame at the moment. No, but
it's okay.
Cool.
It's been 15 years, Marco. It's hard to get everything right within those 15 years.
Yeah.
Hundreds of features, multiple, I guess, dozens of major releases, and I guess more to come.
Right, more to come. Which kind of brings us back to the 15 years of TeamCity. Hopefully today we gave you a tiny glimpse of, what TeamCity has been like with the quiz, what features were when available, which I actually do find super interesting to find that out. And also not just the past, but also the present, a bit of the future. And we have good news for you, because I think we're going to release a couple of more tiny pieces and nuggets of behind the scenes and information about TeamCity's past in the next couple of weeks, but you'll have to stay tuned for a tiny bit for that.
Right. Follow us on Twitter at TeamCity, sign up for our blog. Visit our website from time to time to see what the new features have been released.
And you can always send me also just an email to marco@jetbrains.com if you want. Get in touch. I mean, we'd really like to get in touch with you, talk with you, find out what you're working on, what kind of problems or issues you have. We're here to help.
Right. With this, I think we can wrap it up. It was a big pleasure for me.
Yes, for me as well. It was a great. Also, let us know in the comment section, please, what you think of the format, if you'd like to see more of that. But apart from that, I think we're pretty happy with it. And which basically means we're going to say goodbye now until next time. Or, as we like to say in German, tschüss. And hope to see you soon.
Yes, bye.
Bye.